In the last video we learned Coulomb's law told us that the static electric force between two particles is equal to Coulomb's constant, which is K is equal to 9 times 10 to the ninth. What was it? It was let's see, we want to get newtons meter squared per Coulomb squared times the charge on the first object, or the first point charge, times the second charge, divided by the distance between them. So that's great. If I gave you both charges, you could figure out the force, and you knew how far apart they were. But what if I only gave you one of them? And I said, well, I'm going to give you one charge, and do as much math as you want, and then I'm going to later give you a bunch of other charges, and then I want you to figure out the force. Well, then you could kind of do your work ahead of time, and you could say, well, if I just have one charge here, so let's just say I have one charge. I don't know, let's call that charge, let's call it big Q. Although we could have called it little q. If we have one charge there, let's figure out ahead of time what the force would be if I'm given another charge later on. So what am I saying? So if the force between this charge and another charge is going to be, let's call the other charge the imaginary charge that's not there yet. Let's call that Q2. So we already know what the force between these two are. It's going to be, so the force is going to be Coulomb's constant times big Q, which is the charge that we're given or that we're starting off with, times Q2 divided by the distance squared, right? At that point, if Q2 is right there. But I just said, we don't know what Q2 is. We just want to do enough math ahead of time so that when someone gives us a Q2, we can very quickly, at any point in space, figure out what the force would be. So to do that, what we could essentially just say is, well, then what is the force per charge? So let's divide both sides of this equation by Q2. And I'll get rid of this little sub e because I think it'll just confuse things. So the force per charge, per wherever Q2 is and whatever Q2 is, we don't know what it is going to be equal to K times whatever my charge is, divided by d squared. Right? Wherever that charge I place it, however far it is, that's d, divided by d squared. And this is called the electric field generated by this charge big Q. And what does that do? How does that help us? Well, if you think about it, we could, let me do it, in fact, instead of just thinking about it. If I were to draw that charge, so let's say it's a point charge right here, that's Q. And then we could say at any point, if I were to place a charge, how strong is the force going to be? Because we can just